Okay, so it's time that we review our notes from today's lesson. So this is the first lesson of the course. We're going to discuss what is chemistry, periodicity, and some key vocabulary that you should know dealing with chemistry and the periodic table. So we're first going to start off with asking ourselves, what is chemistry? Well, chemistry is the study of matter and changes it undergoes. And what's really important this year is we learn about the periodic table, since this will be the foundation of everything that we do, and you will utilize it essentially every day in chemistry class. It's very helpful. You can learn a ton of things just based off of the position that elements have in the periodic table. And importantly, everything that we will be learning about either has this direct or indirect connection to the periodic table. So the word periodic in the periodic table comes from periodicity. Periodicity refers to the recurring or repeating trends of the properties of the elements. So the bottom line is that the periodic table is arranged the way it looks today due to these trends. So you can learn a lot about any element in the periodic table if you can learn these trends. So for instance, if you know the trend that going down a group in the periodic table, the atomic size gets larger. If you just look at the periodic table, then you know that the atomic size of potassium is larger than lithium, since it is lower in the periodic table in terms of going down a column. Like any other table, the periodic table has rows and columns, and we will be referring to what these refer to later. But when you think about periodicity, I would like you to think back to your paint swatch activity. So if we think back to the paint swatch activity, and this is the one again that I had used as my example, if you look and see that it once again goes from lightest to darkest here as you go down a column, we could think back to, again, if we wanted to know something about this particular paint swatch down here, we would know that it's the darkest since it's at the very bottom of a column. And if I didn't know anything about this particular paint swatch over here, I would assume it was closer to violet since it is the furthest right you can possibly get. Now this is going to deal with something very similar to the periodic table, since in the example I had said earlier, if we flip back to here, essentially you can learn a lot about these elements based off of their position. So if we go back to this side, this example of the potassium in the atomic size of potassium versus that of lithium, since potassium is further down a column, we can just assume that it has a larger atomic size due to these trends. So whenever you hear the word periodicity and you have to figure out what that actually means, I would think back to the paint swatch activity, remembering that essentially it refers to how things are organized following some trends, and because of these trends you can learn a lot about an element of the periodic table just because where it is located in the arrangement. So again, if I wanted to learn something about this particular paint swatch down here, I would assume that it is closer to the violet end of the color scheme just because it is furthest to the right, and I know that that is the trend. So the periodic table contains all the ingredients for everything in the universe that contains mass and volume. It's really important that you remember that these are the two quantities that everything contains. Everything has a mass and everything has a volume. And essentially everything in the universe that contains mass and volume is made up of one of the elements or a combination of these elements on the periodic table. So as we're referring to matter and elements, it's important that we know what they are. So matter is anything that contains mass and volume. Again, if you look back at the last part of the notes, everything has to contain mass and volume. So we know that matter, since that refers to anything in the universe, essentially it has mass and volume as well. Elements are the names given to the individual items on the periodic table. So whenever we refer to anything on the periodic table, we'll be talking about the elements. The element symbols are the symbols that represent the element on the periodic table. So all symbols start with a capital letter. Many symbols that have two letters, but the second letter is always lowercase. For example, many of you are probably familiar with carbon or nitrogen. Notice that these symbols for the elements are capitalized. They are just one letter. Something like sodium, if you're familiar with that, is Na. Notice the A is lowercase as it is the second letter. So formulas are when elements combine to form compounds, and a compound is made up of one or more than one element, but it may be two of the same element. So notice here we have some examples of compounds. We have water. This one we'll learn how to name later, and these other two examples. So notice that the first one, which is water, which you might be familiar with, H2O, has two different elements, but something like N2 over here is just nitrogen, and there's two of them. Okay? So again, notice that the compound can be made up of one type of element combined with itself, such as H2 or N2, which were two of our examples up there. Okay, there are many others, and we will be studying a lot of compounds this year, as well as learning how to name something like this in the near future. When we refer to a substance in chemistry class, we're talking about an element or a compound. And when we refer to a mixture, we're talking about when two or more substances are in the same system but not bonded together. So an example would be salt water, and we'll discuss some mixtures more at a later date. So next in class, we want to kind of work through this task. So we're identifying the following as elements, compounds, or mixtures. So for simplicity, I'm going to label these as E, C, and M. So this first one here, number 1, H2O2. We notice that it's not just one thing by itself, which would be an element, whereas it's more than one thing kind of bonded together, so this would be a compound. Mixtures are going to be really easy to spot. It's going to be something that doesn't have a simple formula, something that you know isn't bonded together. There's a lot of stuff. So the only mixture out of all of these that are listed here, these 12 examples, would be sand. So if you think about sand, if you've ever gone to the beach, it is made of a lot of different things that are kind of mixed together, but it's really easy to separate these different items in there. Okay? So if we think back to number 2, again, this is more than one thing bonded together, so it's a compound. Salt, which we don't know much about yet, but it is NaCl, is an example of a salt. That is the most common one that you'll hear. There's many others, but we'll just use that as an example. So if you know that this is the formula for an example of a salt, you would know that it's a compound. It's not one thing by itself. Water is H2O. Again, not one thing by itself, not an element by itself, so this is also a compound. Oxygen. Oxygen is an element when we refer to the periodic table, and the element that lives on the periodic table. However, one note, oxygen is written as O2, so this would be a compound if referring to how it actually exists in reality. The next one, as you notice, there are many different elements that make up this compound, so it's a compound. The next one, same thing. O3, this is an example of a compound that's made up of one particular element, but there's more than one of them, so this is a compound as well. Now, if we look at number 10, it's just nitrogen by itself. There's only one of them. That's an element. Copper, again, we're referring to how it is on the periodic table. We refer to the element by name. It's copper, so that's an element. And iron 2 oxide. So iron 2 oxide is going to be a compound. Again, there's more than one thing that makes it up, so therefore it's a compound. So there's 2 examples of elements and 2 more examples of compounds on the bottom. There are many examples of both of these, so I won't go over them, but we can go over them more in class with the examples that you came up with to see if they are valid.